In this video, we're going to review Chapter 3, starting with the atom, which consists of an electron cloud with negatively charged electrons that have negligible mass very far away from a nucleus that consists of positive protons and neutral neutrons, which both have a mass of 1 atomic mass unit. The protons are what identify the element. The neutrons hold together the nucleus, keeping the positive charges from repelling each other into space. And the electrons are what participate in chemical reactions, forming chemical bonds. The atomic number is just the number of protons. It's sometimes symbolized as Z. The mass number is just the number of protons plus neutrons. If you look at a symbol on the periodic table, the whole number that's smaller, that's going to be your atomic number. Next, we have isotopes, which are of the same element, yet different masses. All three of these are isotopes of hydrogen, since they all have one proton, and that one proton defines them as hydrogen. If we want to name isotopes, we put a dash and then the mass number after the name. Another way of symbolizing isotopes is to use this notation where we have in the top left the mass number and in the bottom left the atomic number coming before the symbol. Next, we have ions, which are of the same element but having a net charge. On the left, we have a lithium atom where there is no charge net because we have 3 positive protons and 3 negative electrons. However, on the right, there is an electron missing. We have a lithium ion. If an atom loses electrons, it takes on a positive charge, and it is a cation, which is positive. And if an atom gains an electron, it becomes a negatively charged anion. As the cation is positive, so are cats. Average atomic mass is next. That is a weighted average of the masses of different isotopes. For example, chlorine, which has one isotope called chlorine 35. Of all the chlorine atoms in the world, 75.78% of them have this mass. It also has a second isotope, chlorine 37. If we take the mass and multiply it by the decimal form of the percent, we can add them up and we will get the average atomic mass. Next, we have the mole, which in chemistry is not an animal. It is a name for a number. Avogadro's number, that is, which is a number of things in the mole. Just like a dozen is a name for 12, a mole is the name for 6.02 times 10 to the 23rd. The molar mass is the mass of 1 mole of a substance. So when we look at this 12.0107, that is the mass of 1 mole of carbon in grams. So if we want to do some mole calculations, we could be asked how many moles are in 3.01 times 10 to the 23rd atoms of carbon, in which case we will take that number of atoms and multiply by 1 mole over 6.02 times 10 to the 23rd atoms, and we will cancel out our atoms to get units of moles. It happens to come out to 0.500. Next, we could take it one step further and find the mass of these atoms. Note that here, the atoms cancel, but we just need to tack on another conversion factor, canceling out the moles. We can say that there are 12.01 grams of carbon in 1 mole, getting that from the molar mass from the periodic table. And what this comes out to is 6.01 grams. That's all for this video. Hope it's helped. Feel free to leave any comments and questions in the comments section below, and thank you for watching.